Okay. I'm going to be going through the handout from Unit 1.8. Okay, so in this main class objectives were to understand about pressure, sound power, sound intensity, sound pressure, and also sound pressure level. Okay, so first of all, the important thing to think about here is what is the sound actually doing? So say we have a loudspeaker or something that's generating sound. It's going to send out sound waves. These are representing, say, the wave fronts, the like peaks of the waves. And then in between those peaks would, say, be the troughs of the wave. So for sound, the blue would be regions of maximum condensation. And then the troughs would be the rarefaction. Okay. Now, the thing that starts from the source, our little source here, okay, this sound source, emits a certain amount of sound power. And that is the energy per unit time. Okay, so if you go by a loudspeaker, it might be a 50-watt loudspeaker, or it might be a 100-watt loudspeaker, and that's all telling you how much energy per unit time it can put out. So once that wave leaves, that 50-watt wave, then it gets spread out over bigger and bigger spheres, essentially. If we consider our source now a point source, then you basically would be taking sound over, pretend that's a sphere and not just two-dimensional, and then that same amount of sound would have to cover larger and larger and larger spheres. And each of those spheres would have a different radius. Say R1, R2, R3. Okay. And the surface area of the spheres is 4 pi times the radius squared. Okay. Okay, the intensity is the measure of how much sound per unit area, how much energy per time per unit area. So it's the sound power per unit area at a specific point. So the power is related to the source. The intensity is related to where you are standing or measuring. Okay? And so using this equation for the area, we get then that the intensity is the power, sound power and power are the same here, divided by 4 pi r squared. That can be rearranged to give you this equation right here. Okay. So the intensity as a function of distance. So if the radius decreases, intensity decreases. You know that from real life. If you move farther away from the loudspeaker, it sounds quieter. Okay. But the ratio at which that happens is 1 over the radius squared. So the distance squared. Okay. But we're not actually going to use that. Okay. What we are going to use instead, okay, is the sound pressure. The pressure decreases as the radius increases. Sorry, right with my arrows so I get it right. And do the if first. If the radius decreases, the pressure decreases, but the pressure decreases as is proportional to 1 over r. So what does that mean? That means that if the radius is doubled, so you're twice as far away, then the pressure is halved. And conversely, if the radius is halved, the pressure is doubled. Okay, so that right there, the pink is the answer to this question right here. Okay, so now doing an example of that here in this question number 1. So at 2 meters from a loud source. Okay, so let's get our source. Let's draw where we're at. We're going to be 2 meters away. Okay, at 2 meters, the pressure is 200,000 micropascals. And then the question is, okay, if I double that distance out to 4 meters, what is my pressure? The first thing you say to yourself is it going to be bigger or smaller? Is it louder or quieter if I go farther from the source? So we know it is going to be quieter. And then you say up here, because R is doubled, the pressure is halved. So that makes it 100,000 micropascals out there. So B is the answer. Now the next one, you're interested in half a meter right here. But you need to think kind of about the intermediary step, right? Okay, so if the radius is halved, then the pressure is doubled. So that means when I go from 2 meters into 1 meters, then I'm going to have 400,000 micropascals. And then if I halve the distance again to a half a meter, I will go to 800,000 micropascals. So that is why the answer to that one is C. Okay. But we don't usually talk in micropascals. When we talk about sound, we usually talk in decibels. You can see the lecture for the reason on that, but basically this here, pressure is on a linear scale. So pressure in pascals or micropascals is on a linear scale. Okay. Sound pressure level, which we abbreviate SPL, is in decibels, which we abbreviate dB, are on a logarithmic scale. Okay, so this is our equation to go from the pressure right here to the sound pressure level, which is what the SPL stands for. Okay, for our class, this is very important. Whenever we're talking about sound pressure level in air, we will use the reference pressure of 20 micropascals. Okay. And then this is the inverse relationship. So those are our two equations. Those equations will be on the test. You just need to know how to use them. So number 3 here is, what is the sound pressure level corresponding to a pressure of 20 micropascals? Okay, so we have pressure. So our equation, sound pressure level is 20 times the log of P over P ref. Okay. Just so I have enough room. And then, so for this case here, the sound pressure level is going to be equal to 20 log 2000 micropascals over 20 micropascals. Okay, and the that gives us, okay, so I can do it in my head shortcut way, but I'm going to tell you how to do it on the calculator. Okay, step 1, divide 2000 divided by 20. Same units, so that's good news. And there you should get 100. Number 2, press the log button. Okay, if you're using your phone for if you're using your phone, then you might have to turn to landscape mode to be able to get it, but log of 100 should give you 2. And then you multiply by 20. And you will get 40. Okay, so that's just to kind of help you see how to go. The next one, you would go through those same steps, but you would be saying that sound pressure level is 20 log, now we're going the opposite equation. Okay, so now we're going to be doing this equation here. So we have P is equal to P ref, which is 20 micropascals, times 10 raised to the 20 decibels divided by 20 decibels. Okay, and so on your calculator here, you would divide 20 by 20. You get 1. Then you would take push the 10 to the X button on your calculator, and you would get 10. And then you would multiply by 20 to get 200 micropascals. Okay. And then in this last one, sound pressure level at a specified distance from a source, calculate the sound pressure level. Okay. The important thing is that if you double, so if the pressure doubles, which would happen when the radius is halved, remember? If the distance is halved, then the sound pressure level goes down by 6 dB. So that's this case. And if the pressure is halved because the radius is doubled, then use the sound pressure level increases. You know it has to get, sorry. Okay. Got myself all mixed up. Let me try one more time. If the pressure doubles, the distance is half, it has to be louder, so the sound pressure level goes up by 6 decibels. Okay. If the pressure is half, because the distance has been doubled, then the sound pressure level decreases by minus 6 dB. So if you are 2 meters from a loud source, here's my loud source. Here is my 2 meter mark. 4 meters, 8 meters, 1 meter. Let me just get some distances on there. Okay, 2 meters from a loud source, sound pressure level is 80 decibels. So here it's 80 dB. At 1 meter, I have halved the radius, so the sound pressure level goes up by 6 decibels. And then what is the sound pressure level at 8 meters? So I start here at 2, and then I double the distance, which means I half the pressure, which means I go down by 6 decibels, so I get 74 dB. And then the next one, I'm going to double the distance again, which halves the pressure again, which gives me a minus 6 dB, which gives me 68 decibels. Okay. Now, last but not least, this number 4, see the table in the chapter and learn these levels. You will need to memorize these for the test. It's just so that you have a reference point when somebody says, oh, that's an 80 decibel sound, or that's a 70 decibel sound, or a 40 decibel sound. You'll be able to say, oh, that's like this or that or that. So you just need to only memorize these ones that are specifically listed. Okay. But you should look at that table in the chapter. Okay. All right. Hope that helps.